Hey guys, this is Neha from Edureka, and I welcome you all to this session on exception handling in Java. Errors happen at any time, but what matters is the way we handle and rectify them to maintain the normal flow. Java, being the most prominent object-oriented language, provides a powerful mechanism to handle these errors and exceptions. And effective exception handling makes your program more robust and easier to debug. In this session, I will talk about the fundamentals and various methods of Java exception handling. Let's look at the topics to be covered in this session. First and foremost, I will tell you what exception handling is. Then, I will give you a comparison between errors and exceptions. Next, I will give you an overview on exceptions hierarchy, and you will also understand the difference between checked and unchecked exceptions. After understanding these fundamentals, let's hook into the programming part and learn the basic syntax of exception handling. Once we are done with the basic syntax, then I will be explaining you the types of exceptions in depth. After that, we will dive into the various methods of exception handling along with examples. And I will wrap up the session by giving you a difference between throw and throws, and also between final, finalize, and finally. Also, we will be seeing about custom exceptions and how to parse an exception. So let's begin the discussion and see what exception handling is. Exception is a problem that arises during the execution of a program. It can occur for many different reasons. Say a user has entered an invalid data, or a file that needs to be opened cannot be found, or you can also say that a network connection that has been lost in the middle of communications, or the JVM has run out of memory, many such cases. But if we do not handle them, it leads to a system failure. So handling an exception is very important. And that's where Java introduced exception handling mechanism to handle the runtime errors so that the normal execution flow will not be disrupted. For example, class not found, IO exception, SQL exception, etc. Now let's move ahead and see the difference between error and exception. First, errors are impossible to recover, but exception can be recovered by handling them. Next, errors are of type unchecked, but exceptions can be either checked or unchecked type. Just wait a little while and you will know what are checked and unchecked type of exceptions. And errors are something that happen at runtime, but exception can happen either at compile time or runtime. Exceptions are caused by application itself, whereas errors are caused by the environment on which the application is running. So these are the key points of difference between errors and exceptions. Now, let's see what is exception hierarchy. All exceptions and errors types are subclasses of class throwable, which is the base class of hierarchy. Here, one branch is headed by exception. That is, this class is used for exceptional conditions that user program should catch. For example, say null pointer exception, runtime exception, etc. And other branch error are used by the Java runtime system to indicate the errors that has to do with the runtime environment itself, that is JRE. For example, virtual machine error or stack overflow error, etc. So how Java virtual machine handles exceptions? Whenever inside a method, if an exception has occurred, then the method creates an object known as exception object and hands it off to the runtime system. And this exception object contains name and description of the exception and also the current state of the program where exception has occurred. And creating the exception object and handling it to the runtime system is called throwing an exception. Then, using try, catch, finally methods, these exceptions can be handled. So this is how Java virtual machine handles exceptions internally. Next, let's see the differences between checked and unchecked exceptions. In simple terms, exceptions that happen at compile time are checked exceptions like IO exceptions, etc. And runtime exceptions are called unchecked exceptions like divide by zero, array out of bound, null pointer exception, etc. Basically, unchecked exceptions are built-in exceptions in Java. So checked exceptions cannot be simply ignored. The programmer should handle these exceptions. And runtime exceptions are ignored at the time of compilation. Now, let's see the basic example of exception. So here I have defined the class, and inside the main method I have a try block. So in this try block, the code that we are going to write may raise an exception. That is, it contains the code that raises exception. And then The raised exception will be handled in the catch block. So let's see a small program as how it occurs. First, I will create a new package called exception, Edureka. And now I'll create a new class called sample exception. Finish. So inside the class, the first thing that we are going to do is we are going to write the main method. So here I will create a string str and make it as null. So now after this, I will try to retrieve the length of the string. So when I execute this program, it will throw an exception. Why? Because the string is null and we are trying to retrieve the length of the string. As I said, it throws null pointer exception because the string is null. It does not contain any values. So now let's use try and catch method to handle this exception. So what I'm going to do here, in try block, I'm going to write the code that will raise an exception. Say I have given a as 30 and b as 0. Now I will try to divide a number by 0. Like int c is equal to a by b. So just tell me what happens here. Now say if we try to divide a number by 0, then it says we cannot divide the number by 0 because it raises an arithmetic exception. Correct? So let's see how that occurs. Now, as it throws an exception here, so what I'll do to maintain the normal flow of execution, I will write the catch block to handle this exception. That is, okay, let's run the program and see the output. So as I told, the exception has been catched by catch block. So here first it will throw the exception and then it goes to the catch block. Catch block handles the arithmetic exception E. So it prints cannot divide a number by 0. So this is how exception handling works. Now let's see the various types of exceptions. So in Java, there are two types of exceptions. One, built-in exceptions, and the other one, user-defined exceptions. First, let's see what is built-in exceptions. These are the exceptions which are available in Java libraries, and they are suitable to explain certain error situations, like arithmetic exception, array index out of bound exception, class not found, IO exception, runtime exception, number format, etc. So let's see an example and understand how built-in exception works. So this example is one type of exception, that is arithmetic exception, where we try to divide the number by 0 and it results in arithmetic exception and we have catch the method. So let's see one more example of that kind now. I'll use one more try block. Here what I'm going to do is I'm going to declare an integer number and try to parse a string variable. So what happens? It's an obvious fact that it throws an exception. So let's see how. So just tell me one thing. I have declared an integer number and trying to parse a string variable. So what happens? It obviously throws an exception. Now, in order to maintain the normal flow, we have to handle this exception. So I'll use a catch block and handle the number format exception. So now let's execute and see. First it said cannot divide by 0 because we handled arithmetic exception. And next we handle number format exception. Next we will see how array index out of bound exception occurs and how it can be handled. So here you can see I have created an array of size 5. And now I'll try to access the 7th element in the array. So what happens after this? It will obviously throw an exception. Why? Because the size of the array is 5 and I'm trying to access the array that is out of bound. So what happens when I catch the exception? It says array index out of bound exception. Sorry, it is array index out of bounds. Now again, let's execute. As I said, again the array index out of bounds exception got handled and it printed the output. So this is how built-in exceptions are present in Java libraries. So now I will jump into the methods of exceptions because you need to know the throw and throws methods to understand user-defined exceptions. After I complete the methods of exceptions, I will explain you the user-defined exceptions. So these are the various methods of exceptions, that is try, catch, finally, throw, and throws. Let's see each of them. First, try. Try block is used to enclose the code that may throw exception. The syntax is as follows. As you have already seen, it's very simple. We write a code that throws exception and we can handle it using the catch block. Next, nested try. Nested try block is nothing but a try within a try block. For example, you can see here I have declared one try, and inside that I have created one more try catch, and there is one more try as well. So let's see a small example as how it works. So I'll do one thing here. I'll give a try block within a try block, and then after catch I will end this statement, and after that I will print like system.out.println. Let's print some other statement. Just look at the program. First, what I did. So from here I have modified the program. I have given one try block, and inside one try block I have given one more try and catch block. Okay. And now I have created one more try catch and handled here. After that, what I'm doing, I'm just giving a statement as print other statement. After that, I'm closing this try block. Then I'm again catching the exception and handling that. Okay. So within this one try block, there are two try blocks. So that's how nested try can be used. So let's see the output. See, first it's saying that cannot divide by 0 because it was the first thing that we have done. And within the try block, it said number format exception because the first try block got executed. And next, for this one more exception that it threw, it said it handled. And again, it's printed other statement. That's all. Because we are not declaring anything in the other try block, that is the main try block. So it is not printing that exception. If this try block has thrown any exception, again that would have been printed. But as there is nothing, it's not printing. So this is a usage of nested try and how it can be declared, and this is how it works. Now, let's see the usage of catch block. As in these previous examples, you have already seen how it can be used. And there's also one more thing, that is multi-catch. That is, if you have to perform various tasks at the occurrence of various exceptions, then you can use Java multi-catch block. So here you can see you have one try block and you have multiple catch blocks. So let's see how that works. I'll modify this program only for you. So here I have one try block and I have two different catch blocks. Let's execute and see. So first it printed number format exception, and then it printed other statement. Why this exception did not get handled? Because there was no any exception that was being thrown for this. Okay. If there was any exception that was thrown, then it would have been handled. So this is how you can use multiple catch blocks. Next, we'll see finally. Finally is a block that is used to execute important code such as closing connection, stream, etc. No matter whether exception is handled or not, finally block will always be executed. So in the previous example, you saw that after declaring a try block, you must use catch block to maintain the normal flow. But on using finally block, the catch block is not required. Let's see how. I'll do one thing. I'll remove all the catch blocks here. So I just have a try block. Now I'll give finally and print the statement. Okay. So now let's execute this. As I said, we have not used catch block. It throws the exception. But even on throwing the exception, the flow will not be disrupted there because we have used finally block to execute the code. So you can see the finally block is always executed. So that's how it works. Next, let's see what is throw. Throw is nothing but a keyword which is used to throw an exception. So you can see the syntax here. Inside a method, you are throwing an exception. Let's see how it throws an exception. Let's modify this program. First, I'll define the function here. So inside the throw block, I'm going to throw an arithmetic exception. Okay. Now let's handle the exception using catch block. I'll close this average function and call this function in the main method. So first I throw the exception in try block and catched it. And now I'm calling the entire function in the main method. So let's see what will be the output. It's just telling the exception is being caught. Correct? Why? Because when we call the average function in the main method, it goes back to the loop. The exception will be thrown, but it has been catched. Correct? So this is how throw is used to throw an exception, and it can be handled in the catch block. Simple? Let's see what is throws. Throws is also a keyword which is used to declare the exceptions. It does not throw any exception, but it specifies that there may occur any exception in the method, and it is always used with the method signature. Let's see how. Again, I'll modify this program itself. As I have told it is used with method signature, I'm going to use the throws keyword along with the method. And I'm also using a throw keyword to throw the arithmetic exception. Now, inside the main method, I'll use a try block. So this is an example wherein I'm using the throw keywords along with the method signature. And inside this, I'm throwing a new exception. But when I'm calling the method or a function inside the try block in main method, it will throw an exception. So instead of handling it, I'm just printing the finally block. So let's see what happens. So you can see here first the inside average function is printed, and then it says that there is an exception in the main method. That is, we are throwing an exception. As we are not handling that, at the end it's printing the finally block. Simple? So this is how throws is used. Next, let's see the difference between throw and throws. First, throw is explicitly used to throw an exception, but throws is used to declare an exception. We have already seen how it worked. Next, checked exceptions cannot be propagated using only throw, but checked exceptions can be propagated using throws. Throw is followed by an instance and throws is followed by a class. And throw is always used within a method, and throws is used with the method signature. And throw can throw only one exception and not multiple exceptions, and throws can declare multiple exceptions. Just now we saw how it worked. Next, we'll see the difference between final, finally, and finalize. So final is a keyword, finally is a block as we saw, and finalize is a method. Final is used to apply restrictions on class, methods, and variables. But finally is used to place an important code. And finalize is used to perform cleanup processing just before the object is garbage collected. Coming to final, the final class cannot be inherited, and the final method cannot be overridden, and the final variable cannot be changed. Coming to finally, it will be executed whether the exception is handled or not. We already saw how it worked. Now, let's see a user-defined exception. Sometimes the built-in exceptions in Java are not able to describe a certain situation. In such cases, a user can also create exceptions, and that are called as user-defined exceptions. There are two important points. First one, a user-defined exception must extend the exception class. The second one, the exception is thrown using a throw keyword. So let's see how it works. I'll modify the same program. First, inside the try block, I'll throw an exception using throw keyword. I will handle the exception using catch block. I'll close the class. Now I will extend the exception using extends class. So let's parse some argument here and let's try to print the output. So let's parse some argument as we have thrown a new exception, and when I'm extending my exception, then what happens? Let's see. I've saved the program and I'm giving the value of A to B. Okay. Now let's see what will be the output. As expected, it should print the value as 5. Let's see whether it prints the same prescribed value or not. Exactly. we got the output as desired. That is, the throw keyword is used to create a new exception and throw it to the catch block. And then it got handled, and when extending that, we will get the same desired output. So this is how you can create a user-defined exception. Now coming to the end of the discussion, let's see what are custom exceptions and how to parse an exception. I'll modify the same program again. So in this case, if the number that we entered is more than 100, then it should throw an exception. Else, it should print the provided input is valid. Let's see how. After that, I'm reading a number here and then trying to validate the input in try block. If the input is not validated, then it will be handled in the catch block. Again, this is a user-defined exception, so it must extend the exception class. So this is how I have created custom exception. So let's run the program and check what will be the output. So it's asking to enter the number that is less than 100. So I'll enter 99. Says valid input. Again, I'll run the program. Now I'll enter 101. It says input is greater than 100 and it caught the exception. That is, I have mentioned here, if the number is greater than 100, then it should throw an exception. And that exception is caught in the catch block. So this is how custom exception can be used in Java. Now let's also see how to parse an exception. In this case, we are going to parse a simple date format. So for that, I need a java.simpleDate format package. I'll import that now. I'll make the class as public and let's write the code. For the simple date format, I'm going to create a reference called SDF. So I'm going to parse the input date that we enter. So this is very simple. I'll tell you how. If we enter the date in this format, then it should print as valid input, or else it should throw an exception. Let's see how to do that. So in the try block, first I have read the input date and then output date. I have created a reference for them. And if there is any error in case of changing the date format or while converting the date formats, then that exception will be handled in the catch block. And next, in the main method, I have used a scanner class to read the format. So let's run the program and check the output. So first, let's enter the date format which is invalid. So I'll give something. So it's telling that some error has occurred while converting the date formats. So it's telling exception is here. That is when we are trying to parse the exception. And the unparsable date will be so and so. Now let's execute it one more time and enter the proper date format. That is 01011996. So it's telling after changing the date format, it will be this. That is the one which I have given in this format. From the input date format, which is in day, month and year, it changed the output date format by parsing the input date to year, month and day. Correct? So this is how we can parse the exception. So that brings us to the end of the session. I hope you have understood the concepts of exception handling. That's all for today. Thank you and have a nice day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!